Dear students, welcome back to a new mathematics session. In the previous session, we have discussed the basic concepts of trigonometric functions and we have solved first four questions from exercise 3.3. Hope you have revised well. In today's session, we shall discuss question number 5 to 15 from exercise 3.3. Before starting the session, please make sure that you have recalled all the formulae which we have learned from the chapter trigonometric functions. Let's move on to the topic. Let's begin with question number 5. Find the value of sine 75. So sine 75 we are asked to calculate. First of all, take this number 75, and this 75 in terms of trigonometry functions, it is an unknown quantity for us because in the tabular column format we have learned the values of 0, 30, then 45, 60 and 90 degrees. But this 75 is not familiar for us. So what we have to do is we have to split this 75 and we have to write it as per our known quantities. Means 75 we can split as 45 plus 30. 45 value also we know, 30 value also we know, third function values. So for 75 we have to split as 45 plus 30. But 75 we can split some other way also, like 50 plus 25. But it is of no use because 50 and 25 and all we don't know the trigonometric function values directly. So let's split like this. Now it is in the form sin x plus y. Sin x plus y, there is a formula sin x cos y plus cos x sin y. So just in terms of x 45, in terms of y we have to put 30. Substitute sin 45 into cos 30 plus cos 45 into sin 30. Replace x and y with 45 and 30 respectively. Now we have to write down these values: sin 45, cos 30, cos 45, sin 30. Previously what we do is we just formulate a table, and from the table we will derive by using the values 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. Here I am not showing that, I am trying to write directly because by this time you should be able to write it directly. If you are unable to do so, then just go for making the table of your own and write. Here sin 45 value is 1 by root 2, cos 30 value is root 3 by 2, cos 45 value is 1 by root 2, sin 30 value is 1 by 2. Now only the calculation part is there. I am taking root 2 outside from the denominator. Of course 2 also is there common, but I am taking only root 2 for easy calculation purpose. So 1 by root 2 if I take, then in the first term there is root 3 by 2 plus in the second term there is 1 by 2. Then inside the root, if you take inside the bracket, if you take 2 as common LCM, numerator will be coming root 3 plus 1. Directly we can add because it is having a common denominator. So the answer will be coming as root 3 plus 1 by 2 root 2. Or else without writing this step, just for understanding purpose this one is done. From here directly also we can write because you can see here 2 root 2. Here also 2 root 2. If you take 2 root 2 as common LCM, 1 into root 3, 1 into 1, 1. So directly also you can write, it's not a problem. Tan 15 is next question. So tan 15, when we write it as tan 45 minus 30, because 45 minus 30 we are getting as 15, and 45 is known to us, 30 degree also known to us in terms of trigonometry function values. This is in the form tan x minus y. Tan x minus y is tan x minus tan y divided by 1 plus tan x tan y. You should be able to recall these formulas. If you don't know how to write these formulas, then these problems you will not be able to do. So make sure that these formulas are recalled whenever it is necessary. Then tan 45 minus 30 means tan x minus y format. When you write tan 45 minus tan 30 divided by 1 plus tan 45 into tan 30. Then tan 45 value is 1, tan 30 value is 1 by root 3, 1 plus tan 45 value is 1, tan 30 is 1 by root 3 again. Then little bit of calculation. In the numerator root 3 we can take common LCM, then root 3 into 1 is root 3 minus 1, and the denominator root 3 into 1 is root 3 plus 1 divided by root 3. LCM I think you know how to take. Then when we write it this one, root 3 minus 1 by root 3 into denominator's reciprocal we are taking and multiplying, that is a root 3 by root 3 plus 1. Denominator is root 3 plus 1 by root 3. When you multiply it, take the reciprocal and multiply. Here when you check, there is a root 3 is common, so just you can cancel root 3 and root 3, and root 3 minus 1 by root 3 plus 1 is the answer. But when you check the denominator, it is in irrational number form, so we have to rationalize. So rationalization, we know that just root 3 minus 1 by root 3 plus 1, that is our answer. But this root 3 plus 1 is irrational number. Take the conjugate of this one. Conjugate means just opposite sign you have to take and multiply in the numerator and denominator. Here root 3 plus 1, conjugate is root 3 minus 1 with opposite sign. Multiply it in the numerator and denominator. Here root 3 minus 1 into root 3 minus 1 numerator, that is root 3 minus 1 the whole square. Denominator is root 3 plus 1 into root 3 minus 1, keep as it is. Then a minus b the whole square expansion we know, a square plus b square minus 2ab. So just expand it, a square root 3 square, then plus b square is 1 square minus 2 into ab, root 3 into 1 it's written. Denominator same again, root 3 plus 1 into root 3 minus 1. Then root 3 square is 3, 1 square is 1 minus 2 root 3 divided by root 3 plus 1 into root 3 minus 1. Then here when you check 3 plus 1 is 4, 4 minus root 3 divided by, this is a plus b into a minus b form. A plus b into a minus b is a square minus b square. If you want to do both the calculations together here, you can go for it, it's not a problem. Suppose if you may feel confused, that's why just doing these two calculations separately. But if you wish to do here, you can directly substitute this formula. A minus b into a plus b is a square minus b square. That is 4 minus 2 root 3 divided by root 3 square is 3 minus 1 square is 1. Then here in these two there is 2 common, you can take out. First time 2 going means 2 balance minus 2 root 3 2 going out means root 3 balance divided by 2. And here when you check there is again common, 2 is common, just to cancel it and 2 will be cancelled. And then we will be getting as 2 minus root 3. So this is the value of tan 15 degree. Next we shall discuss question number 6. Prove that cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y is equal to sin of x plus y. Here left side you can just write as it is, that is equal to, here you can see cos a plus b. Cos a plus b is cos a cos b minus sin a sin b. You can just check here, cos a cos b minus sin same angle a sin b same angle, this one. Okay, so this is in the format cos a cos b minus sin a sin b. We can write it as cos of a plus b, that is equal to cos of a, what is a, pi by 4 minus x, plus what is b, pi by 4 minus y. Then cos of pi by 4 minus x plus pi by 4 minus y. What we have done is just we have removed these brackets. Actually nothing to remove here, but since we use brackets here, the same brackets we have used here also. And in this step we just avoided the brackets, that's all. Then that is cos pi by 4 plus pi by 4, these two pi by 4 I have taken together, then there is minus x and minus y, that is equal to cos pi by 4 plus pi by 4. Just calculation is there. When you do the calculation here, pi by 4 plus pi by 4, when you take denominator, common denominator, that means both 4 only, so just write 4 as common denominator. Pi plus pi will be coming as 2 pi, and when you cancel this one, 2 and 4 will be coming as 2, so pi by 2 will be coming here, that is what it is written. Then in these two terms there is minus common, when you take minus of x plus y will be coming, that is cos 90 minus theta is sin theta, or cos pi by 2 minus theta. Cos pi by 2 minus theta is sin theta. How we have to derive that I have told you in the previous slide also, previous section also. There is a 2 axis we have to draw. Pi by 2 means it is in the y axis. Y axis means the function will change. How will change means cos will change to sin. So our output will be sin. And pi by 2 minus x plus y is our angle. Pi by 2 minus means it will be coming here in the first quadrant. First quadrant all are positive. So cos will be changed as sin, and the sin is positive. So sin of x plus y. This is the way we have to derive, or else directly we can write sin cos 90 minus theta is sin theta. Hence the proof. That is what we need the answer, sin of x plus y. Move on to question number 7. Prove that tan pi by 4 plus x divided by tan pi by 4 minus x is equal to 1 plus tan x by 1 minus tan x the whole square. So tan x plus y, there is a formula, tan x plus tan y divided by 1 minus tan x tan y. This is in that format. And again there is another format, tan x minus y. Tan x minus y means tan x minus tan y by 1 plus tan x tan y. By using these two formulas we can split the numerator. Tan pi by 4 plus x is tan x plus tan y. Tan pi by 4 plus tan x by 1 minus tan pi by 4 into tan x. Then tan pi by 4 we know that is tan 45, that is 1 plus tan x divided by 1 minus, here also tan pi by 4 value is 1. So 1 into tan x is tan x. Then the denominator part, tan pi by 4 minus x, if you take tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x, means formula is tan x minus tan y by 1 plus tan x tan y. This formula we have used. Again substitute tan pi by 4 value. Tan pi by 4 is 1 minus tan x by 1 plus tan x. Here also tan pi by 4 1. How we have done the first part? The same thing, only the signs are different, that's all. Then tan pi by 4x plus x divided by tan pi by 4 minus x, that is our left hand side. We have calculated these two, just keep it in the numerator and denominator. So 1 plus tan x divided by 1 minus tan x divided by 1 minus tan x by 1 plus tan x. These two values we have substituted in the numerator and the denominator. Then as before, there are two terms, two fractions in the numerator as well as in the denominator. So denominator fraction we will take the reciprocal and multiply with the numerator. So 1 plus tan x by 1 minus tan x, that is what the numerator. Then we change division as into multiplication. Then take the reciprocal of the denominator, means 1 plus tan x by 1 minus tan x. Now you can check here 1 plus tan x in the numerator, here also 1 plus tan x. Two same quantities multiplying time 1 plus tan x the whole square. Denominator also same thing, 1 minus tan x into 1 minus tan x. When we multiply these two, 1 minus tan x the whole square will be coming. This is our right hand side. So we can say we have proved the statement. Next we shall discuss question number 8. Question is, prove that cos pi plus x into cos of minus x divided by sine of pi minus x into cos of pi by 2 plus x is equal to cot square x. This question you will try it as homework, and you have to try it without any reference and try to find out the answer by solving the left hand side, and you have to bring the answer as cot square x. Unless or otherwise you have the practice of solving these type of questions by applying the formula from your memory. It will not be possible for you to solve these questions when it is asked for the examination. Next is question number 9. Proof cos of 3 pi by 2 plus x into cos of 2 pi plus x into cot of 3 pi by 2 minus x plus cot 2 pi plus x is equal to 1. Here you can see there 3 pi by 2 plus x, 2 pi plus x, 3 pi by 2 minus x, 2 pi plus x. All these formulas we have learned. So we are not going to use our memory, but we are going to derive it from the axis. So first one, cos of 3 pi by 2 plus x. Let me draw the axis somewhere here. So there is x axis, and this one is considered as y axis, and here will be coming as pi and 2 pi angles, this portion. And in the y axis, when it comes pi by 2, multiples of pi by 2, pi by 2, 3 pi by 2, and so on. So here if it is 6, that is 3 pi by 2 here. So first one is, just check the first one. First one is cos 3 pi by 2 plus x. Cos 3 pi by 2 plus x means it is in the y axis. You can see here this is in the y axis. Y axis means function will change. How function will change? Cos will change to sine. So the output will be sine x. Next we will check the sine. Here 3 pi by 2 plus x. 3 pi by 2 plus x means from here moving that side. Means it is in the fourth quadrant. And when you check in the fourth quadrant, you can we have learned a short form. In the first quadrant, all means add, sugar means sine and cosec, 2 means tan and cot, to coffee means it is cos and sec, means in the fourth quadrant cos and sec will be positive. So here it is cos only, so output will be in positive sign. So we will be writing as sine x. Next is cos 2 pi plus x. Cos 2 pi plus x, it is 2 pi. 2 pi means it is in the x-axis. X-axis means function will not change. So cos means cos only. And 2 pi plus x. 2 pi plus x means it is in the first quadrant. The first quadrant all are positive. So cos x is positive. The next is cot 2 pi plus x. Here it is cot 2 pi plus x. Again the same thing. It is 2 pi is in the x-axis. So the function will not change. Cot remains cot only. 2 pi plus x means it is in the first quadrant. So positive cot x. Next is cot 3 pi by 2 minus x. As before, 3 pi by 2 means it is in the y-axis. Function will change. Cot will change to tan. So your output will be tan x. Then next we will check the sign. 3 pi by 2 minus x. 3 pi by 2 minus x means it is in the third quadrant. Third quadrant means tan and cot will be positive. So cot is surely positive. So the output will be tan x. So all the values we have got, let's substitute. That is cos 3 pi by 2 plus x is sin x. Cos 2 pi plus x is cos x. Cot 3 pi by 2 minus x is tan x. And cot 2 pi plus x is cot x. We have substituted. Then sin x into cos x into, then here tan x plus cot x, just we are reversing the order, cot x plus tan x we have written. Then sin x into cos x into, inside the bracket we will change it as sin and cos, in terms of sin and cos. So cot in terms of sin and cos is cos by sin, plus tan in terms of sin and cos is sin by cos. Simple calculation inside the bracket, take the LCM, sin x into cos x. Then cos x into cos x plus sin x into sin x. That is sin x into cos x, the outside bracket is the same thing. Cos into cos is cos square x, sin into sin is sin square x. By denominator is sin x cos x. Then here we can say cos square x plus sin square x. But just what we have done here is the common denominator is there, sin x cos x, that we have cancelled. And then cos square x plus sin square x, directly we can write the answer as 1 because it is the identity. So that is what our right hand side. So we can say hence proved. Next we shall discuss question number 10. Prove that sin n plus 1 into x into sin n plus 2 into x plus cos n plus 1 into x into cos n plus 2 into x is equal to cos x. So this is in the format sin a or sin x sin y plus cos x cos y. So this formula we have seen here. Cos a cos b plus sin a sin b, cos a cos b plus sin a sin b is cos a minus b. This is in that format. So here we can write cos a is n plus 1 into x minus b is n plus 2 into x. That is written cos a minus b. Then cos of, remove the bracket, n into x n x, 1 into x is x, minus n into x is minus nx, minus into plus is minus, 2 into x is 2x. And when you check here, there is plus nx and minus nx we can cancel, and we will be getting as cos of x minus 2x. Cos of x minus 2x is minus x, so cos of minus x. Cos of minus x, we know the formula, that is cos x. So this is a result, cos of minus x is cos x. This is our right hand side, that is our RHS, so hence proved. Next we shall discuss question number 11. Prove that cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is equal to minus root 2 sin x. Here when you check, it is in the form cos x minus cos y. Cos x minus cos y we know that is equal to minus 2 sin x plus y by 2 sin x minus y by 2. This is what the formula we are going to use. So let's take the left hand side. Then minus 2, here you can see minus 2 sin, that is written. Very carefully you have to write x plus y, means angles sum divided by 2. Here these are the angles, 3 pi by 4 plus x and 3 pi by 4 minus x. Sum of these two angles divided by 2. Then difference x minus y, that is this angle minus this angle, that is what it is written, divided by 2. Here visibly some calculations are there that we can do, plus x minus x we can cancel, and here 3 pi by 4 minus 3 pi by 4, these two we can cancel. Then we'll be getting as minus 2 sine, you can see here 3 pi by 4 plus 3 pi by 4. 3 pi by 4 plus 3 pi by 4 means when we add two same quantities, we'll be getting as 2 into 3 pi by 4. This is what the answer will be coming. So 3 pi by 4. Then you can see here 2 and 4 we can cancel and we can write 2 times. So we'll be getting the final answer as 3 pi by 2, that is written. Denominator there is a 2 that is mentioned. Then here x minus into minus plus. So plus x. X plus x is 2x divided by 2. Now you can check these 2 and these 2 we can cancel. So minus 2 sine, here these 2 will be coming in the denominator. So 3 pi by 4 into 2 cancel, then we'll be getting a sin x. Then minus 2 sine, just 3 pi by 4, we don't know exactly the value of this 3 pi by 4. What we can do is convert it into degrees. So 3 into pi replace with 180 by 4 into sin x. Then minus 2 sine, this 3 into 180 by 4, when you do the calculation will be coming as 135. Minus 2 sine 135 into sin x. Just to do the calculation here and check whether you are getting 135 or not. Please do not copy. Minus 2 sine 135 into sine x. Next, 135 also not familiar for us. So we have to split minus 2 sine 135, we can write as 180 minus 45. 180 minus 45 is 135 into sine x. Then here sine 180 minus theta, we have learned as sine theta. Sine 180 minus theta formula is sine theta, that is 180. 180 means pi minus theta. Sine pi minus theta is sine theta. Then minus 2 sine theta. Sine theta means here theta is 45. So sine 45 into sine x. Then minus 2 sine 45, familiar for us, 1 by root 2 the answer, into sine x. Then here you can check, there is a minus 2, here there is a root 2, means rationalization should be done, means the denominator is having only irrational number. So when we write this is minus root 2, minus 2, we can split as root 2 into root 2. We have learned before also this, that is when two root numbers multiplying time, root 2 into root 2 is 2. Okay, that is what the concept here, root 2 into root 2 is 2. So that is what we have written here. 2 we have replaced as root 2 into root 2 divided by 1 by root 2 into sin x. Then 1 root 2 we can cancel here. 1 root 2 if you cancel, denominator problem is solved. So we will be getting the answer as there is a minus root 2, there is a sin x, minus root 2 sin x. That is what our RHS. So we can write it as hence proved. Move on to question number 12. Prove that sine square 6x minus sine square 4x is equal to sine 2x sine 10x. So left side is somewhat familiar for us because this is in the form a square minus b square. Let's try for that. Sine square 6x minus sine square 4x. This is a square minus b square, that is a plus b into a minus b. Sine 6x plus sine 4x into sine 6x minus sine 4x. Then let's take these two separately and solve. Sine 6x plus sine 4x. Sin x plus sin y. Sin x plus sin y is 2 sin x plus y by 2 cos x minus y by 2. That is what the formula, that is 2 sin sum divided by 2, sum of the angle 6x plus 4x divided by 2, then cos difference of the angle divided by 2, 6x minus 4x by 2. That is 2 sin 6x plus 4x is 10x by 2, here 6x minus 4x is 2x by 2. Cancellation can be done here, 2 and 10 5 times, here 2 and 2 cancel. So 2 sin 5x cos x. Then same way there is one more portion is there, sin 6x minus sin 4x. This is sin x minus sin y. Sin x minus sin y, we know the formula 2 cos x plus y by 2 sin x minus y by 2. Means sum divided by 2, difference divided by 2, and here first is cos, second is sin. So that is 2 cos 6x plus 4x by 2, then 6x minus 4x by 2. That is 2 cos 6x plus 4x is 10x by 2, 6x minus 4x is 2x by 2. Here also as before 2 and 10 we can cancel 5 times, 2 we can cancel. Then here cos 5x sin x will be coming. Then let's put it together, that is sin square x minus sin square 6x minus sin square 4x is equal to, we have got the answer, these two terms we have split it and just substitute. First part answer we got 2 sin 5x cos x, second part answer we got 2 cos 5x sin x. Then here 2 sin 5x cos 5x, there is a grouping we need to do. Okay, angle you have to check, here there is 5x, here there is 5x, there are 2's are there, so 1 2 we have to take and same angles, sin 5x cos 5x grouped. Then again one more 2 is there, that one, and angle with x cos x and sin x, that is written. So 2 sin x cos x, then here also 2 sin x cos x. So this is the formula of sin 2x. Sin 2x is equal to 2 sin x cos x. So here x is 5x, instead of x here 5x is there, that means first part will be coming sin 2x, our x is 5x, 2 into 5 is 10x, here our x is only x, 2 into x, that is 2x. Okay, sin 2x, that is the answer we need. Sin 2x means double of the angle, here angle is 5x, double of that angle is 10x, here the angle is x, double of that angle is 2x. So sin 10x into sin 2x, this is what our RHS. So we can say it is hence proved. Next we have to discuss question number 13. Prove that cos square 2x minus cos square 6x is equal to sin 4x sin 8x. Similar to the previous question, so you will try it as homework. Question number 14, when we do, prove that sin 2x plus 2 sin 4x plus sin 6x is equal to 4 cos square x sin 4x. Here Sine 2x plus 2 sine 4x plus sine 6x. That is what LHS. When we take, just group it, sine 2x plus sine 6x. These two we can group because here there is a 2. So just we have to keep it separate. First and last we can keep it together so that it is in the form sin x plus sin y format. So sin x plus sin y is 2 sin x plus y by 2 cos x minus y by 2. That means 2 sin sum 6x plus 2x divided by 2, then cos difference 6x minus 2x by 2 plus 2 sin 4x. 2 sin 6x plus 2 is 8x by 2, cos 6x minus 2x, that is 4x by 2, then this term as it is plus 2 sin 4x. 2 and 8 we can cancel and write 4. Here 2 and 4 we can cancel and write 2. So 2 sin 4x, then here cos 2 and 4 cancelling time will be getting 2. So cos 2x plus 2 sin 4x. Then 2 sin 4x is common in this term and here in the second term also. So just to take it as common factor outside. Then in the bracket balance in the first term 2 sin 4x going means cos 2x is balance, plus in the second term entire term is outside as 2 sin 4x. There is only one balance, so it is written cos 2x plus 1. That is cos 2x, we know the formula, 2 cos square x minus 1. 2 cos square x minus 1. So that is 2 sin 4x into cos 2x we have written as 2 cos square x minus 1 plus 1. This cos 2x we have changed as 2 cos square x minus 1. It's written. Then 2 sin 4x into, here you can check here, minus 1 plus 1 we can cancel. Okay. This minus 1 plus 1 if you cancel, after cancellation there is only 2 cos square x is balanced, that is written. Then 4 will be coming here because there is a 2 here and there is 2 inside the bracket also. This 2 and 2 multiplying together will be getting as 4. Then here it is sin 4x into cos square x. So that is what the answer. Here when you check 4 cos square x sin 4x, of course order is not same but it's not a problem. 4 sin 4x is there and then here cos square x also is there. That is what our RHS, hence the proof. Next we shall discuss question number 15. The question is, prove that cot 4x into sin 5x plus sin 3x is equal to cot x into sin 5x minus sin 3x. Here left hand side and right hand side, when you check more or less the pattern is same. You can see here there is a cot x and there are some of 2 trigonometric functions are there within the bracket. Here also same thing, outside is cot x, there is difference. So what we have to do is we have to do LHS and RHS separately we have to do, and we have to find out the answers and we have to prove that they are same. So solving LHS, when you take cot 4x into sin 5x plus sin 3x, that is here inside the bracket when you check it is sin x plus sin y. Sin x plus sin y is 2 sin x plus y by 2 cos x minus y by 2 formula. That is cot 4x is outside into here inside the bracket when you check 2 sin sum of the angles 5x plus 3x by 2 into cos difference of the angles 5x minus 3x by 2. This formula we applied. Then cot 4x into here 2 sin 5x plus 3x is 8x by 2, then 5x minus 3x is 2x by 2. Here 2 and 8 we can cancel, 4 will be coming, this 2 will be cancelled and only x will be coming. Then 2 cot 4x into 2 sin, here answer will be as I said before 4x, here cancellation after, that is cos x. So 2 cot 4x sin 4x cos x. Then 2 here cot 4x in terms of sin and cos, there is a formula, that is cos 4x by sin 4x, because cot theta formula is cos by sin, cot theta formula is cos by sin. So cos 4x by sin 4x, then there is a sin 4x here, again cos x. Here when you check there is common term in the numerator and denominator, we can cancel. Then there will be 2 cos 4x and cos x, that is what we have got the final LHS. Then when we are moving on to the right hand side, because when you check the left hand side there is no connection with the right hand side, so we need to do separately the right hand side and we have to make it equal. That is what we are going to do. Cot x into sin 5x minus sin 3x. You see here this is in the form sin x minus sin y. Sin x minus sin y is 2 cos x plus y by 2 sin x minus y by 2. That is cot x is outside, 2 cos sum of the angles 5x plus 3x by 2, Then sine difference of the angle by 2, that means 5x minus 3x by 2. That is cot x into 2 cos 5x plus 3x is 8x divided by 2. 5x minus 3x is 2x by 2. Here 2 and 8 we can cancel, right, 4 times. 2 and 2 completely can cancel. That is cot x into 2 cos, as I said before, this is 4x, and here it is sin x. Then again there is 2 cos 4x into sin x. This cot x we have changed as cos x by sin x. And as before, we can cancel, there is a common term, sin x and sin x we can cancel, and there will be balance 2 cos 4x and cos x. You see here on the left side we have got the same before, 2 cos 4x cos x, means the left hand side and right hand side are equal. We can say that we have proved our given statement. Dear students, today we have discussed question number 5 to 15 from exercise 3.3. I request all the students to solve these questions in a separate sheet of paper, and while practicing, make sure that you have recalled the formulas whenever it is necessary. And while practicing, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.